Hey, hello, welcome to the my ninth day. And today I started too strong, and it is a great day. First of all, congratulations. It's my ninth day. Continuously, I'm working on. Okay. And the second thing is, uh, today, yesterday I reported a issue in the ISP, and that is not that is making some troubles to me, and my GitHub.com is not loading. Today it is failed. So keep it up from that side. And today I started strong. Then in a mid time, like in the noon, I slipped off a few things. But if you say from the last 8 days, it was the quite good day, and I learned a lot of things today. Let's see what I learned today. And today, if you see, I have been looking into the from we can just see the VS Code. Here I fixed some things. Two questions of two pointer. Looks little silly, but yeah, really I only able to solve two pointers of two questions. The time looks like 3 hours, but I didn't take took 3 hours. I just went away, left the things running, and then go away to do something. So, but yeah, it is still a long time to do this small thing. And the problem was not that hard if you say that, but the issue was I was facing a very serious issues nowadays. The thing is, I moved to the complex implementation of the things. I start thinking, how can I just do the small thing and can uh, compress the solution's length instead of looking at the clarity of the length. And I put the if else conditions in the same things, and it become a cumbersome. So now I decided, first of all, go and look into the like use your copy pen, solve the problem there, then try to make it readable most of the time. That will solve the problem, and that solved the problem for next time. That worked for the next time. And yeah, and then after these questions, I worked on matrix. What is the matrix? Matrix is a kind of two-dimensional array, sorts of, and yeah, that stores the data in a two-dimensional array. That's it, I know. And I solved some of the problems based on it. Those were pretty easy, so I solved them. And then I moved to the stack. And stack is a data structure that stores data, and it works the principle of LIFO, last in, first out. It's kind of a stack of the books. So if you want to pick the book from a container, then you have to remove the all the book from whichever you put at the last, right? So that is the core principle of a stack. And you can build the stack based on the linked list array. Those are the things you can do. And yeah, so I basically read about the stack, what it is. And I also did one more thing. If you go here, algorithm and data structure, I wrote it down some things. So if you see the rendered view of it, so I wrote about stack. There are few operations about stack. Uh, Pop, push, empty, and peak or top. Right. So push, pop, peak, and empty. And you know these operations, bigger notations. So time complexities are big of one for each of them. And use cases are great. If you know the browser history, Yeah, that works on based on the stack. Completely true. Browser history. And then the function stack or function callback stack. And yeah, some expression evaluation or undo function in software applications. Dealing with the stack overflow and yeah, there is something that is called overflow or underflow in the stack. Suppose you have a stack of size, or suppose if you see a container, if the container size to fit only 10 books, you can't fit into the 11 book, then it might fall or something. So that is overflow. And if it is a already empty and you want to uh, grab one book out of it, you can't because it's empty. So those are the underflow and overflow. Then, yeah, I already wrote about the array. One interesting thing you might see here. Okay, so if you see that earlier I was having multiple pictures inside the concept. Similarly, I might have in the problem. Okay, not in the problem. But if I go to some other project, system design algorithm. Okay, system design also I don't have. But what I did actually, I created this setting.json file. So you remember I'm using one extension, paste image, and I just configure it, nothing much. So if I copy an image and try to paste anywhere, suppose I want to paste it here, and then I just need to do this the name of the file, name of the file, and control option command option B. Here is your file. See, you can see it right away. And you want to see you have it here. And this is I copied recently. This is that file only, and it is stored in assets and images. Automatically goes there. Pretty simple. Right. One more thing I want to tell you. If you don't use command and option, then what will happen? If you directly command V, then it will create a image inside the folder that you don't want, right? So that's the one optimization I did to my productivity. That's great. Yeah, that's kind of great. And then load balancing. Too much shout out to the load balancing. Great work because it took me a lot of time to read the whole thing. So I read about the load balancing, everything of it. What is the load balancer? Load balancer is a traffic, okay, network traffic distribution system that send the as a request to a uh, s- like send a request to a server, backend server to handle the load evenly. You can say evenly, but it is depend on the what algorithm you are using. So there are a lot of algorithm for load balancing, right? So first of all is pretty simple, round robin. So what it do, if you have this, okay, so what it do is pretty simple. Suppose suppose you have four servers, one two three. This hand is my load balancer. So what it will do, it will one request come up, and this load balancer receive it and then send to this one, and then next one it this send this one, and then again in a cyclic order it will send the request accordingly to the servers. It don't care about what one server is have load of. He don't know. Suppose this server is a small one which can't sustain the load of multiple requests, then this load balancer don't know about that. So it is not aware of the capacity of the servers, and it is not the aware of the active connection of the server. That's the problem of it. But it is good for homogeneous system, and it is simple to implement, and yeah, and it is stateless also. So then come to the picture, the next one, least connection. And the least connection is the good one. So what it check, it check always the which server have the how many connections. Based on that, it receive the request and then send to the respective servers which have the least connection at that moment. But it can create or spike the network, right? Why request spike might happen at that moment? Why is that how can happen? Suppose there are short-lived requests are there, and then in that case it might suppose it rebalance again and again based on the how many least connection those have, like which one have the least connection, right? And it is kind of stateful. Okay, and then so it is good for heterogeneous, and then we have weighted round robin. But the least connection system is least connection load balancer is quite complex to implement, because we have to take care of the metrics of these live servers, and it need to be aware of the these. But there is a problem. One problem is that it is not aware of the capacity of these. So I don't know, like if it is a small server and it can handle on three requests, but all of them already have three requests, and it will all of them have four requests, and it will send the next to this small server only, because you don't know about the capacity. Then come to the picture of weighted round robin. Weighted round robin is simple. You to solve the problem of like the server capacity, what it do, it will set the weightage on based on the server. If it is a small, then it will set it to the smaller number, so it will send a less request to this one. Weighted round robin, it will solve the round robin's issue of not awareness of the capacity. Then it come to the weighted least connection. It is pretty like quite interesting. What happens? It will solve the problem of least connection on load balancing. The issue was it was not aware of capacity. Now it is aware of capacity based on the weightage of the. But still, it have one problem. The problem is it still don't know. Yeah, there is a one problem about it. Okay, the weighted list connection. Okay, let me check. I think I missed it somewhere here. Okay. Uh, hmm. Okay. Weighted round robin, weighted list connection. Will all the qualities. So didn't found some of the issues with it, but it has some issues. IP hashes. IP hashes is good for uh, like pretty simple to create, and what it do is it hash the IP address of the request and send to a particular server. Simple. But it don't care if some server is goes down, or if you add some new server. Dynamic systems, it don't like scalability and dynamic systems, it don't consider. So it will have a overhead on the load balance to create new hashes, and it might feel uh, become a stateless, because we see it is a stateful because it always send the service to the request to the server, right? Then after the IP hashes, then you have least response time. So to make the your service system fast enough, so you can use one more matrix, that is least response time. If a server is taking a least response time, it will send request directly to it. Simple as that. Nothing. Random. Random is pretty great for the homogeneous system, and if the system capacity is exactly approximately same in response, and then it will send randomly. If the random function is good enough, it will send the request evenly to all the servers. Pretty simple, no need to look. Then least bandwidth. And least bandwidth is good if you are streaming a video or something. Then if the request is sending to a one bandwidth of particular backend server is least, then it will send to that the direct request. No worries about anything else. And then custom loads, you can set your own metrics. Not, no one will be stopping you from doing that, right? So what are the use cases of the load balancing? You know, like it optimize optimize the system, improve the scalability and availability and reliability, and then network optimization, geo distribution, and a lot of things, right? Those things I read into this, and then after that I started this React video that I was kind of looking into it, but the problem is that it is giving me some errors. Maybe you can't see it, but I will be showing you. Now you can see that these are the errors it is giving to me. And it is saying, because I'm trying to install the React 19. I didn't say install the React 19. I just say React latest one that is stable. And it is giving me this damn error. It's saying that there is some dependencies of 18. It is not. So yes, tomorrow I will do and install the React 18 and then try to use it. Simple as that, right? Okay, cool. So this was the my day, and thank you. Bye bye. Good night.